When a commercial tanning salon powers up brand new, factory-certified equipment, the baseline assumption is that the hardware has never been safer. But the biophysics of ultraviolet generation dictate the exact opposite. The installation of fresh tubes actually initiates the highest period of acute physical risk to the end user. This heightened danger exists because commercial UV output is governed by a strict, non-negotiable threshold. This blueprint illustrates the threshold. When fresh tubes are installed, the irradiance output instantly spikes past the red horizontal line labeled 0.3 watts per square meter, the EU's absolute limit. Pushing past this rapidly accelerates the likelihood of severe thermal injury and long-term carcinogenic risks. If an operator treats a Sunbeds output as a flat, stable constant out of the box, they will inadvertently expose clients to dangerous levels of radiation. Maintaining compliance requires operators to actively track and manage the changing state of the hardware. The 0.3 limit is a hard biological ceiling, and brand new equipment possesses the volatile physical capacity to break right through it. To understand why fresh equipment is so volatile, we have to look at the specific physical properties of fluorescent ultraviolet tubes. This line graph maps UV irradiance on the y-axis against time, measured in hours of use, on the x-axis. The glowing horizontal line establishes our absolute safety ceiling at 0.3 watts per square meter. Plotting the output of a brand new tube starting at hour 0 shows an intense energy spike, pushing dangerously close to, or even briefly over, that legal line. During this initial burn-in phase, new tubes operate at absolute peak intensity, heavily overperforming their standard baseline metrics. As the timeline tracks forward through 10, 20, and 40 hours of continuous use, the output remains highly elevated and unpredictable. Applying a standard 10-minute exposure during this window delivers a massive UV overdose. The hardware only stabilizes at a specific threshold. Exactly at the 80-hour mark, the curve dips, degrading smoothly into a predictable, safe plateau. This physical degradation curve is the exact reason regulators enforce License Condition 9Q. Under this condition, operators are required to proactively reduce the manufacturer's recommended exposure times throughout that high-output window. Alternatively, compliance can be achieved by prominently displaying warning signs that explicitly advise users to reduce their own exposure times until the tubes mature. Failing to meticulously track these operating hours means a business is blindly exposing clients to uncalibrated, peak-level energy. Hardware output follows a degrading curve, not a flat line. Ignoring the physics guarantees accidental overexposure during those critical first 80 hours. The output of the hardware is only one side of the equation. We also have to account for the receptor, human skin. An identical dose of UV radiation triggers vastly different biological consequences, depending entirely on the person absorbing it. This visual matrix outlines the standard biological diagnostic tool used in regulatory compliance, the Fitzpatrick scale, ranging from a very fair type 1 to a deeply pigmented type 6. The scale measures a person's inherent melanin levels, establishing a direct baseline for their physiological susceptibility to ultraviolet damage. If we apply a uniform 10-minute dose across the board, the results diverge sharply. A type 4 profile registers a safe response, while the exact same exposure applied to a type 1 profile triggers severe erythema, or acute burning. Relying on a static operational timer for every client ignores these physiological differences and constitutes physical negligence. This is why health and safety regulations demand a comprehensive client assessment prior to any machine use. This assessment requires specific contraindication checks, identifying skin disorders, current medications that induce photosensitivity, and determining the correct Fitzpatrick type. Establishing this biological baseline is the only accurate way to determine a single person's individual threshold for irradiance. The strict hardware limits engineered into a commercial sunbed offer zero protection if they aren't directly calibrated against the specific biological vulnerability of the person inside it. These two halves of the risk assessment process merge into a single operational workflow. Here we have the tube degradation graph on the left and the Fitzpatrick matrix on the right. Safe UV compliance acts as a dynamic equation, continuously linking the degrading output of the machine to the variable biology of the human. If we connect a sunbed running new tubes at the 20-hour mark to a vulnerable type 2 client, we create a high-risk scenario. To resolve this safely, the equation calculates a reduced exposure time, ensuring the total dose remains under the 0.3 threshold. That exposure time only scales upwards if the tubes move past their 80-hour plateau or if the client possesses a more resilient skin type. The sole purpose of continually adjusting these variables is to ensure the SCCP effective irradiance limit is never breached. True operational compliance relies on constant active calculation. Safe tanning is a rigorous physical process, never a passive assumption. The core objective of these regulations remains straightforward: prevent acute thermal injury today and mitigate severe carcinogenic risks over the long term. This local authority operating license, overlaid with regulatory mathematics, highlights the commercial reality. Adhering to the 80-hour rule and conducting precise biological assessments protects the business's legal license just as much as it protects the client's skin. Upgrading to fresh equipment will always create the highest operational danger zone, demanding the highest level of vigilance. In commercial UV operation, safety is not guaranteed simply by purchasing factory-new hardware. It is guaranteed by mastering the physics of the equipment and the biology of the exposure.